Everyone, in this video we'll be solving a new problem, and in this problem we are going to traverse in a binary tree in post order basically. Previously we solved traversal in binary tree in pre-order traversal, but in this problem we are performing traversal in post order. And post order, what we want is in we want the output in this particular order, that is left subtree first, and then we want to go to the right subtree, and then only to the root node. So that is the order we want. And if you look at example 2, that might make it more clear. This is a binary tree. First of all, we want to go to the left. So the left of 1 is 2. Now 2 is again a root node for 4 and 5, so we're going to again go to the left, which is 4. So 4 is a leaf node, so we want to print this 4 to the output. And then finally, after I print the left, I want to go to the right, which is 5. Now 5 is again a root node of 6 and 7, so we want to go to the left, and 6 is a leaf node, so we want to print 6 to the output. So after 4 it's 6, and we have a right of 6, which is 7, and 7 is leaf node, so we want to again print the 7 to the output. And then finally, after we're done with left and right, we want to print 5, which is the root for 6 and 7, and that's the order we are looking at in the output. So that is our post order traversal, and this continues until we get all the nodes in the list, output list. So that is the order. Now if you look at the right, that's the solution I've written in iterative order. If I had to write this in recursive order, it would be very trivial, like we discussed earlier. It would we would finish the solution in a couple of lines. So this is a iterative process. So what we are doing here first is checking if the root node is none, just like earlier, and if it is none, then it means that we don't have any nodes, so we want to return back empty list. That makes sense. Then we are solving this problem using two stack method. So we can also solve this problem using one stack problem, but it becomes really difficult. So for now we are solving this problem using two stack, and therefore I've initialized two stacks, stack 1 and stack 2. Now stack 1 I have initialized with root node inside a list, just like what we did in previous pre-order traversal. I've also initialized stack 2, which is an empty list, and then I have iterated using while loop until stack 1 has some elements in it, just like in the pre-order traversal, right? And inside the loop, I'm first popping the last element of stack 1. Initially we are popping the root node, so that's in the node, and then we're checking if there is any left subtree. If there is, I'm appending the left subtree to the stack 1, and if there is right, then I'm appending the right subtree to the stack 1, and then I'm finally appending the value at the root node to stack 2. And if you've noticed, at the end I'm returning stack 2 as our answer, and before I return, I've also reversed the order, right? So if you've realized, you see the root is the last element I want in our list, and here in the solution I've appended the root node first, and that's why if I reverse the order, the root node becomes the last element. And so in this inside the iteration, you can see there are two conditionals, and I'm checking first of all if there is left subtree. If there is left subtree, I'm appending the left subtree first to stack 1, and if there is right subtree, and I'm appending the right subtree second. And very interestingly, that's the same order we want our elements to be. We want first element to be from the left subtree, then right subtree, then root. And it makes sense that I'm actually checking and appending the subtrees in that same order. But then the stack 1 is popped every single time I iterate, and it is popped in reversed order. It pops the last element, which is the right subtree. So in the node, I'll be assigned the right subtree first before the left subtree, right? So what's happening is that I get the right subtree first, and then I append the value of right subtree to stack 2. So what's happening is that I got the root value first, then got the right subtree values, right? And then only I got values from the left subtree. And thankfully this reversing stack 2 before returning the stack 2 helps a lot, because now I can revert the order back to which we wanted. We wanted first to have left, then right, then root values, right? After reversing, we get the right order and we are returning it. So if I run this, it should pass all the test cases. It does, and if I submit it, that's the solution. That's right, that's the solution. So